Hi again, welcome back. If you're here, that means that you have a working IDE software on your computer, and this is exciting because we're going to get to play today with your board and control some light. So let's get started. What we're going to start with is we're going to I'm going to take you through an overview of the IDE software to see the different functions, the important things that we're going to be working with, and then we're going to control an LED, and I'll explain how to do that. Okay, you'll need your PC or laptop where you have the IDE software on, your Mega 2560 board, and your USB cable to connect your Mega 2560 board to the computer. So don't do it yet if it's not connected. We'll do it in a minute together. It's going to take you about an hour. This video is shorter, but there's going to be some exploration that you'll have to do to kind of practice some of the concepts that I'm going to teach you in this video. All right, so let's look at the IDE software. When you open the IDE software, automatically it opens what's called a sketch, and a sketch is your place to write the code, which is just a list of instructions that you basically transfer to the microprocessor and tells it what to do. And it's written not just in regular English, it's written in a certain language that has some rules based on the program language that's used. And in this case it's C++, but you don't have to worry about that because you don't have to write a lot of original code, and what you're going to change and write on your own is going to be pretty self-explanatory to you. One thing that I wanted you to notice is whenever you open the software, it gives it automatically a name. So this is the file name that it gives it, and it calls it, it's a default, calls it a sketch underscore and the date. So it's July 8th when I took this snapshot and the picture, and that's why the file name is like that. Okay, so that happens automatic. All right, so let's look at the menus, at the commands that it has. So under File, the File menu option, it has a lot of commands that you typically see under File. You can open a new sketch, you can start a new sketch, you can open an old sketch, you can open recent sketch. If you've been working on some files and programs, if you click on that, you'll see maybe the last 3 that you've been working on. And today we're going to actually open an example. So IDE comes with a library of a lot of code that's already been written that can help you do a lot of things already, and we're going to leverage that. Why invent the wheel if somebody else already wrote the code? There's enough to do even without writing the code. You can close the file, you can save as, and you can even print. Okay, the next, let's look at the edit. The edit commands are also very typical: paste, copy, font size. If you have a hard time reading the font, it's kind of small, you can increase the font size and so on. Sketch has a couple of interesting commands that will be important, and we'll use them all the time. The top one is verify/compile, and every time we write a code, we want to verify that the code is written according to the computer language we're using, or have the right, what's called syntax, or follows the rules. Okay, so we'll click on the verify. What it also does, and it will show us if we made any error in writing it, and it can show us where we made the error, and then potentially we can fix the error. It also compiles. So compiles meaning it takes the code that you write. It's kind of it has these commands, but it's really not a language the microprocessor can understand. A microprocessor works with zeros and ones. It knows how to send voltage. It turns them on and off to different places and pins on the board. That's all it knows. So it compiles that set of codes that you wrote into something that your microprocessor can understand. So that's a very important step that we'll take every time that we'll write a new code or make a change to a code. We want to verify, and we want to make sure that the language fits what the microprocessor can read and execute these commands. The other one that's interesting right under verify and compile is the upload. So the upload, it's actually when we click on it, this is when the code that's been compiled actually moving through the USB cable onto the microprocessor. So that's, once you upload the code, that's when the microprocessor start using this code. Okay, so that will be very important. In fact, these commands are so important that they have a shortcut on the main sketch, and the verify and compile is this check mark, and the upload is actually the right facing arrow. So we don't have to go to the sketch menu every time we want to do these two commands. All right, let's see what else. Oh, the tool. Tool is very important. You don't use it a lot, but at the beginning you will use it, and that's the first time today that you'll have to use and make some changes here. The first thing I want to point out is the board. So go ahead and find the tools menu and click on the board options. You'll see a lot of options. Remember I told you that Mega is not the only option for microprocessor or boards. You have the Leonardo, the Uno, the Nano, a lot of other different boards. So when you open this list, you see a lot of them. So go ahead and select the Arduino Mega or Mega 2560, just like mine, because that's going to tell the computer, all right, this is the microprocessor I'm working on. So when it does the compiling, it's going to compile it to fit what the Mega 2560 understands. Okay, and after you did that, make sure that the processor that's identified there is also the same as mine, so the Mega 2560. So pause the video and go ahead and do that. Okay, if you're back, that means that you got it right. Right underneath the processor, there's a menu option that says port, and it's gray, it's not black. So what's happening there? That is gray because when I took this screen capture to look at these commands, my Arduino was not connected to the computer via the USB. So when I connected it and took the screenshot of the tools menu, you can see that it's not gray anymore, it's black, and it says COM3. So what is the port? The port is the path of communication between my computer and the board. So when I hit the compile, when I hit the upload, it knows through which channel to communicate, of my computer to communicate with the board. So you don't have to worry about it too much, but you have to make sure your computer identifies some communication path. It may not be COM3 in your computer. That's not something I selected. That's something that came on the screen automatically once I connected. So go ahead and connect the Mega 2560 board to your computer using the USB cable, and check that you have a port communication open. So pause the video and go ahead and do it, and make sure you have a port identified. Okay. All right. Okay, we're gonna start the first program. So go ahead, open the Blink example, and you'll find it after File, Examples, Point 1 Basics, and go pick up the Blink file. And when you open it, it's gonna look like this. And this is a good one to start with. And I just want to show you the layout of the code. How does the code look like? So you have this whole area here that's basically just text. What it is, it's a general explanation of what the code does. And how does the computer know that these are not commands, these are just explanation? It's because they have a special symbol here. Okay, so anything between these two symbols, okay, it's like this special parenthesis, if you want. The computer knows that when it hits this symbol, this is just explanation. It can just ignore. It's just for the reader. It's not for. It's not a command or anything. And once it hits the other end of this special parenthesis, it knows that maybe after that will come command. Okay, so that's a great tool because it helps us to explain what the code does, not just write the code. So if you ever take a thorough programming class, which I hope you will, very important for engineers, you will have to explain everything you do in your code, and that's the right way to write code. So let's read the explanation, what Blink does. Blink turns on LED for 1 second, then off for 1 second, repeatedly, indefinitely. And guess what? Look at what you have here. Do you see the orange LED? 1 second on, 1 second off. 1 second on, 1 second off. So it's already there, it's already doing it. Okay? We'll talk about that in a minute. So this is what it does. That's exactly the blink program. So it's already doing it with the orange LED. Okay, so let's see how it does it. So everything after the explanation basically is code. Okay, but the code is also has explanation in it. So every line that starts with these two slanted lines is an explanation. Okay, so you can see the first one says the setup function runs once when you press reset or power the board. And right under this there's a green word that says void. So every colored word is actually a command. Okay, so that's a setup, that's an initialization, but that basically tells the microprocessor, okay, what I want you to do is send voltage. When I ask you to send voltage, you'll send voltage to a pin that's called LED built in. And that microprocessor already knows that the LED built in is that orange LED, and it knows which pin to send the voltage on and off when I ask him to do it. Okay, right underneath it says a loop. So loop is a command that basically runs indefinitely unless you stop it somehow. Okay, so it runs over and over and over. So under the loop you have several commands. So this whole code is basically just 4 commands, 3 of which I show here. This one says digital write. So write means send voltage. Okay, write to that LED built in, write to that pin, write to that path, to that LED, high. And high means high voltage. That's all the microprocessor knows. It knows send voltage or don't send voltage. So high means high voltage. It's not really high voltage, it's only 5 volt in this case. But for the microprocessor, 5 is high. And then it says delay for 1000. So delay is a time command, right? Okay, so now we have high voltage, we have 5 volt in the LED, and now the next command says delay, wait for 1000. What is this 1000? So the units that's used in the code is milliseconds. Milli is 1/1000th, so 1000 milliseconds is exactly 1 second. Okay, so that's why we send 5 volt to the LED and wait a second. And then the command after says send low voltage to the LED, and low voltage is 0 volt. 0 volt basically turns off. There's no voltage, right? No voltage, no current, then the light is off. And then right after, and I didn't copy it in, it has another delay for 1000, so it waits another second, and that's the reason why it goes on for 1 second, off for 1 second. 5 volt, wait. 5 volt, 0 volt. 5 volt, 0 volt. 5 volt, 0 volt. Okay? All right. Okay, so that's what it does, turn on and off, and wait 1 second in between. So what is an LED? LED is a light emitting diode. It's all over in almost all electronic products. You have LEDs, light indicators. If you start paying attention, you'll see them all over the place. So it's a small semiconductor device. So it's a device that's made of special material where we can control when they conduct current and when they don't, which is very powerful, and that's what makes the light. And they come different colors. In fact, in your kit there's a small box with a lot of LEDs. You have greens and reds and whites and yellows. I'm not sure if there's orange one, but maybe. All right, so remember the time units in our commands are milliseconds, and 1000 milliseconds is 1 second. Okay, so remember that, that's important to you. Now here's an interesting question. How does the board know to do that? We didn't upload that Blink software onto the board, so how does it know? It's a good question, right? Just by connecting the board with the USB cable to your computer doesn't upload the code that you have on your screen. Okay, you really have to hit that right facing arrow to do that. So how does it know? So interesting, this board already came with the blink preloaded inside the microprocessor. So somebody already loaded that program onto the microprocessor. That's how it knew how to do it. But now we're going to start making changes and we'll see the differences. Okay, so before we make changes to any software, the best thing you can do is to save it under your own name, and just save it under my blink, your name blink, whatever you want. Maybe you can make a file folder for all your own coding programs that you'll try, but save it under a different name, because if you play with it and something doesn't look right, you can always upload the original file and go back to the original setting if you don't remember what they were. Okay, so pause and save it, and then we'll continue. So let me just show you again what happens. So if we look at the time scale, and that's called the amplitude, or how much voltage, and between V low and V high, this is 0 volt in our case and 5 volt in our case. So it has high voltage, 5 volt for 1 second, then it drops to 0 for another second, 5 volt for 1 second, 0, and it goes and on and on and on repeatedly. That's called a square wave, and it will be very, very important for us in the future. This is a really good way to control motors, and we'll learn more about it. So pay attention. This is going to repeat again. And what's going to happen? Let's see what's going to happen if we change the first time, the high time, from 1000 to 5000. So any place on your you can go ahead and find that first 1000 where it says delay 1000, the first one, and change the 1000 to 5000. Go up on top to the green command bar, click the verify, and hopefully you didn't get any errors, any red errors. You shouldn't. And then click the right facing arrow, the upload, and you'll see a couple of more LEDs turning on momentarily, and then you see the change. So here's what's going on here now. So the LED doesn't turn on for 1 second and off for 1 second. It turns on now for 5 seconds and off for 1 second. See, so we are controlling this LED, and we can continue playing with it and making some more changes. Okay, so let's make another change. Okay, and don't forget to click the check and then upload if you want to see the changes on the board. Okay, let's change both values to 500, and I'm going to do that right now. 500 and 500. What do you think is going to happen? So instead of 1000, instead of a whole second on and a whole second off, now it's half the time. So it's going to supposed to be half second on, half second off. So I'm going to click the check, the verify, and then I'll upload the software, and hopefully nothing's okay. And here you go. Much faster. Half second on, half second off. Half second on, half second off. Okay, so hopefully you have that too. Let's play a little more. What if we shorten it even more? 50 instead of 500. So instead of half a second or 0.5 seconds, it's 0.05 seconds. It's very fast. So let's see if we can see that. So I'll change it to 50. I'll change both of them to 50. 50 on, 50 off. Hit the verify, hit the upload, have it uploaded, and see how fast it blinks now? Much faster than half a second. So it's 0.05 seconds on, 0.05 seconds off. Pretty cool, huh? All right. Couple of things about this square wave that's going to be important. This is called the period. It's the time span, or the span along the x-axis, between one point on the square wave until we go back to the same point. Okay, the repeating. So this is a period, is one whole wave before it starts repeating and repeating and repeating and repeating. That's called the period. So in our case, if we read the scale, our period is 2000 milliseconds or 2 milliseconds. Okay, so why is that important? So our period is 2 seconds. It's important because we're going to start talking about a variable called frequency. And frequency is 1 over the period, when the period is measured in seconds. So in this case, the frequency, is half a second. Okay, the unit of the frequency is 1/second, or hertz. It's also called hertz. Hertz was a scientist, and he did a lot with electricity, so electronics, electricity. So he has this unit of frequency named after him. All right, so here is an example. In our case, the period is 2000 millisecond, or 2 seconds. So we translate from millisecond to seconds, and then we take the reciprocal of 1/. So half a second, which is the same as half hertz. Okay, so the frequency, or F, is half a second, or half hertz. Okay, so make changes to the times in your code now, and calculate period and frequency to get some understanding of how to do that. Okay, so you can repeat that example. It's very simple. Just do a few of them. So make some changes, and then for each change that you made, try to calculate the period and the frequency. And remember, the period needs to be in second to find frequency in hertz. Okay, not milliseconds. Okay. After you finish playing and making changes, go ahead and there is an assessment. Part of the assessment is just true false. Some of it is calculating frequencies, and some of it is exploration. So you have some thinking problems there to do. And once you finish, submit it, and next time around we're going to start talking about controlling things using what's called a pulse width modulation, a very, very important way to control things on the board. So until next time.